Hey guys, my name is Brathan and welcome to my channel. FDM 3D printing got really popular over the years amongst home users and got really easy to use. It's a great technology which helps you to nurture your creativity. But is it really safe? We're going to talk about it today. Also, we'll discuss some of the safety features which you should seriously consider while you're working on 3D printers. We have Zimpure from Zimple, an air filtration system for 3D printers. We're going to unbox and review it right here in Generation 3D. 3D printing is great, it's cool, but a lot of research has gone into it, showing a substantially high level of VOCs or volatile organic compounds and UFPs or ultrafine particulates gets released during the process. Usually these are long-time processes, and as the time goes by, the concentration of these particulates increases in the air surrounding it. If you inhale that air for a long time, some health issues may arise, like nausea, headache, at times some respiratory problems. It is really important to take care of your health while you're in the journey of 3D printing. If you consider some of the things that we're going to show it right here, this problem can be easily tackled. So let's jump into it. First, let's talk about Zimpure, a air filtration system for 3D printers. A year back, I came across this French Kickstarter company called Zimple, who has put a lot of research in this field just to tackle the UFHs and the VOCs that I've talked about. I've been using it for a year for one of the printers, and I decided to buy another one for my other printer. So today we are going to unbox and review it.
It arrived in a really well packed box. Right at the cover it shows the Purifier is capable of reducing the particulates up to 99% that get released during the 3D printing process.
Let's see what all we've got here. An instruction manual, just 2 pages. Wow. It shows the description of the product, the operation instructions, safety recommendations, and filter placement. I'm going to talk about it in a short while. We've got the suction pipe, the powerful suction unit, the power cord, and a Velcro. Even they have sent me a pack of jelly beans. So now this brings me to the second part, wherein we'll talk about suction heads. In the website you would find 12 different versions that fits your 3D printer.
Just search the printer you have, and if you're lucky, you would find the suction head compatible to your printer. You can download and simply print it. They've got really high quality files that you can use. And it's better to print it with high infill and ABS material. You can just slice it with normal settings and you'll be all set with the suction head.
But it is understandable that it's difficult to design suction head for every printers out there. They've mentioned in the website how to create your own suction heads. So let me show you.
The instructions that they've provided is pretty clear. The idea is to get your suction head reach as close as possible to the nozzle so that the aspiration rate gets to the maximum. I've modeled the suction head for my Monoprice printer in Fusion 360. Let me briefly show you how I've done it. First, you need to have a precise measurement of the entire extruder assembly, as in the fan block and the heated blocks and the nozzle. Once you get that done, you can start modeling the suction head. With the use of Sculpt tool, you can easily design the pipe and then you can model based on the structure of the assembly. I added the G3 logo just to give it a personal touch. Once that's done, simply select model and save the STL and bring it to the slicer. One thing I kept in mind while modeling the suction head that none of the sections should go beyond 45 degrees so that while slicing I would not need any of the support structures. And the design came out precisely what I wanted. Simplify 3D showed it would not need any of the support structures while printing. You can download the design from my Cult Study account. I have made it available for free. I went through a few of the iterations and finally I got the right fit. As the model is made up of ABS, I wanted to smooth it out using acetone paper bath technique. It looked really awesome, but for some reason it changes color from brown to green. I guess I have to reach out to matter hackers to know the reason. Placing the suction head was really simple. I just undid the screws of the fan block and attached the suction head right at that position. Now, as you can see from this angle, the suction head pipe has reached really close to the nozzle, and that was the intention of this entire project.
To install an air filtration system or getting a machine like Zimpure is great, but to ensure that you have no exposure to these particulates, you might consider buying a 3D printer which has got a fully enclosed frame like this. Or if you have a printer which has got an open frame, you might consider this. Creating your own enclosure like this. Let me show you a brief construction montage of this enclosure.
I figured out a plastic cardboard sheet would do the job. So I found an 8 feet by 4 feet plastic cardboard sheet from Home Depot for about just $20. It was easy to cut according to the measurements, and I used hot glue gun to fix all the edges. I also added a LED strip to make it well lit inside the enclosure. And when it all came together, it looked fantastic. Now let's talk about the most vital component, filters. Right under the hood, I found two levels of filtration. First, the P3R filter and another ABEK cartridge. Here you can see how much of dirt got collected on the P3R filter after about 7 months of usage. The filters over here can support up to 500 hours of printing. That's a lot of time. It's quite nice to see that some of the parts in the module are in fact 3D printed. That's really cool.
Alright, let's talk about the heated bed and the extruder. Both these components in a 3D printer needs to operate at certain temperatures. The heated bed works from 60 degrees to 90 degrees Celsius, and the extruder works from 190 to 260 degrees Celsius. So be mindful of this temperature constraint while you approach to your 3D printer. This video was made with the desire of making your workspace to be safe. That's it now guys. If you find this video to be informative, please do subscribe to my channel. If you have any questions, please do write to me in the comment section below. And if you know anyone who is really interested in 3D printing, please do share this video with them. You can also follow me on my Instagram and Facebook accounts at maker.gen3d to tap into my daily updates. I'll be back shortly with another video in Generation 3D. Till that time, please take care of each other and more pop to you, chasing your dreams.
Wow, this place looks really exciting to me.